So there is a spring of spring constant K. It is cut into two pieces. One shorter piece and the other one is a slightly longer one. Such that if this length is L, if this length is say L, this length is 2L. So it will be easier to understand in this term. Then the total original length of the spring will be equal to 3L. So let's try to understand this. A spring of spring constant K, let us assume that having a length 3L. It is cut into two pieces such that one part has a length L, the other part has a length 2L, such that they are in the ratio 1:2. So the longer piece is 2 times that of the shorter piece. Okay, suppose you apply an external force F. Let this spring stretches by some distance. So assume that a spring of length 3L extends by 3x. Then we can write external applied force on this spring of spring constant K is F is equal to K into extension. We are assuming that extension is 3x. But when you apply the same force F on this one of the two pieces which were cut, and we are applying the force on the longer piece of the string. When the spring was originally 3L, the total spring extends by 3x. Now this is only two part of the original one. Hence, if the original spring extends by 3x, this spring of length 2L will only extend by a distance 2x. And moreover, we do not know the spring constants of these two springs. Let us assume the spring constant of this is K dash, the spring constant of this is K double dash. Then this force F is equal to K into extension. Hence F is equal to K dash into extension is 2x. Since we are applying the same force up here, then right hand sides will be equal. So K dash into 2x is equal to K into 3x. Then when you cancel out, K dash is 3K by 2. But what about the spring constant of the shorter one? If you apply a force, same force F, the original spring extended by 3 times x, then this would only extend by 1 times x. Then F is equal to the spring constant K double dash into extension x. But F is equal to K into 3x. So K into 3x. So K double dash is equal to 3K. But let us see our answers are right. When two springs are cut into two pieces, in order to get back to the original spring, you have to connect these two in series like this. We have found that the spring constant of this is 3K by 2, spring constant of this is 3K. When you connect two springs in series, the effective of the spring constant 1 by K series will be 1 by K1 plus 1 by K2. 1 by K1 is 1 by 3K plus 1 by 3K by 2 is 2 by 3K. Then if the LCM is 3K, it is 1 plus 2. So 1 by K spring constant equal to 3 by 3K. Hence it is 1 by effective spring constant in series is 1 by K, which is the original spring constant. Hence when we cut the spring into two pieces, they have two different spring constants. When you connect these two back in series, we have to get original spring constant. We have found two different values, and we just checked if we connect these two different values in series whether we get the original spring constant, which we have got it here. Hence the longer one will have a spring constant of 3K by 2. Then that is our option B.